Today, we're going to dive into some really cool technology that uses a bit of gentle electricity to help your skincare and even topical medicines do their job way, way better. So think about this for a second. You spend your hard-earned money on all these creams and serums, right? They're packed with amazing, powerful active ingredients. But how much of that good stuff is actually getting past the surface of your skin? The answer to that question is, well, everything. To really get why this is a problem, you have to appreciate just how incredible your skin is. It's basically a biological fortress, and it's designed to protect you. But the very thing that makes it a hero for keeping you safe kind of makes it a villain for skincare. See, our skin has all these different layers. Its main job, its number one priority, is to be a barrier. It keeps all the bad stuff out and all the good stuff, like moisture, in. And you know what? It is fantastic at its job. Maybe a little too fantastic. The main part of this fortress, the big wall we have to get past, is called the stratum corneum. It's this super thin outer layer, and it's basically a wall of non-living cells and fats. It's amazing at stopping big, water-loving molecules, what scientists call hydrophilic molecules. The catch? That describes a ton of modern drugs and active ingredients. They just hit this wall and stop dead in their tracks. Okay, so if our skin is this locked-down fortress, how in the world do we get the precious cargo inside without, just knocking down the walls? Well, it turns out scientists have found this really elegant solution. You could call it an electric key. Its official name is iontophoresis. Now, don't let that big sciencey name intimidate you. Iontophoresis is actually pretty simple. It's just using a very, very low-level, totally safe electric current to give molecules a gentle little push across the skin's barrier. We are talking about a current so weak it's considered physiologically acceptable. This isn't a shock. Think of it more like a subtle electric nudge. So how does this electric key actually unlock the door? Well, it works in two main ways. The first is called electrorepulsion, which is just a fancy way of saying what we learned in science class. Like charges repel. So if your drug is positively charged, you use a positive electrode to push it away, and right into your skin. The second way is called electroosmosis. This is where the current creates a little flow that just carries the molecules along for the ride. It's kind of like an electric escort service, guiding them right through the skin's gates. All right, that all sounds great in theory, but does it actually work in practice? Let's take a look at the evidence from this really fascinating bioengineering study from 2023 that shows us exactly what's happening. So what these researchers did was they took samples of porcine skin, that's pig skin, which is a surprisingly good model for human skin, and they put a solution on it that had this fluorescent dye. This way, they could literally see how far the molecules were able to get in. This first setup you're seeing is the control group. It's just the dye, sitting on the skin, no funny business. And, well, no big surprise here. In the control group, the dye just sat right there on the surface. It couldn't get past that fortress wall. The researchers also tried using tiny microneedles to poke little holes in the skin. And yeah, that helped a bit. Some of the dye seeped in, but the effect was pretty limited. But this is where it gets really interesting. For the next test, they used the exact same fluorescent dye, but this time they introduced that gentle electric current. This is the iontophoresis test, the electric key in action. So what do you think happened? The results were so dramatic, so clear, that they actually inspired a really powerful real-world application. The idea was to take this science out of the lab and put it directly into a smart facial mask. And just look at this. The visual results are absolutely stunning. On the left, the control skin barely shows a thing, just a faint little line of dye on the surface. But the skin treated with electricity, it is glowing. The current didn't just help the molecules get in a little bit, it allowed them to literally flood deep into the skin. The difference is night and day. Let's put a number on that incredible picture. When the researchers measured the brightness, they found that the electric current increased the absorption of that solution by about 4.5 times compared to just leaving it on the skin. It absolutely blew both the control and the microneedle method out of the water. And here's the really crucial part. This wasn't just more absorption right at the surface. Nope. The molecules got down to an incredible depth of 320 micrometers. They reached deep into the dermal layer of the skin. That is an absolute game changer for getting treatments exactly where they need to be. Now, to make this something you could actually use, the researchers went one step further. They designed and built this super clever portable power supply. It's incredibly lightweight, looks kind of like an earphone, and it's made to hook right over your ear comfortably.
This tiny little device is what provides the power for a special facial mask that's woven with conductive silver threads. And they tested it out. Applying the mask with the power on significantly boosted skin hydration. We're talking an increase in moisture from around 47% to 55% in just 20 minutes.
But let's be clear, this is about so much more than just getting a better moisturizer. This exact same technology is opening the door for a whole new generation of non-invasive medical treatments. Scientists are already looking into using iontophoresis to deliver powerful biologic drugs without any needles. I mean, just imagine treating serious skin conditions like atopic dermatitis or psoriasis by delivering targeted therapies or potent anti-inflammatory drugs right through the skin. It's even being tested for delivering agents that kickstart your immune system to fight skin cancer. And the vision gets even wilder. Researchers are now testing this technology directly on internal organs during minimally invasive surgery. This could let doctors deliver super targeted drugs to treat diseases like liver fibrosis, or even deliver gene therapies right to the pancreas, all while minimizing the nasty side effects that come with injections that flood your whole system. The researchers who created that smart mask really summed it up perfectly. They don't just see this as a small improvement. They see it as a fundamentally new way to think about how we can use wearable tech to deliver medicine effectively and conveniently. And that kind of leaves us with this huge, fascinating question. Our skin was just the first fortress. If a simple, gentle electric current can be the key that unlocks it, what other tightly guarded barriers inside our bodies could we learn to safely open, completely revolutionizing how we treat diseases in the years to come?